Hello everyone, my name is Nathan and today it's time for another first look / potential series. This time the game is called Hardware Engineering, so it is a slight difference and it's not my fault that all the games I'm interested in have practically the same name. However, contrary to the previous first look, if you have seen it, this is a totally different experience. This is kind of a puzzle game, but much more related to actual hardware engineering reality than any other game I've seen so far. Now this game is incredibly complex and not for everyone. I will probably also reach my limits very quickly, and that's why I thought YouTube is the perfect platform to play this, because you guys can give me your input and so on and so forth. Now I'm not sure if this series would do well, but if it does, I'm definitely gonna pump out more videos about it. Now let's go ahead and have a look into the design mode. I've already played a little bit in the tutorial mode, but I'm actually interested if it's about the same thing. Yeah, it looks as though it's something similar to the tutorial, so we might be able to solve the first 4 puzzles, the logic puzzles. And you can see there is advanced logic and it just keeps going. You can actually make your own memory cells, you know, the logic for memory. And if we go further, then we can make whole processing units, comparisons, shift, holy cow, and then there is advanced programming, rotation, oh my gosh, a calculator, processing designs, we can make control units, input units, this is just amazing. Now of course there's also a sandbox mode, so we can check out all of the components and just, you know, try them a little bit. However, we're just gonna check out the introduction. Now, we are not gonna read this all together. You can read this for yourself in case you do want to buy this game. It's not a lot of monies, so it's definitely worth thinking about it if that is the type of game for you. It doesn't look like much, but it's more about the logic, you know? So the task is you need to design a device that will perform a logical multiplication on inputs A, B, and forward it to the output O. So up here we have our inputs and outputs. Here we have the input A, then we have input B, and also here we have the input O. There we go. Okay, let's continue here. Since this is your first circuit, we will provide step-by-step instructions for you. Okay, we already did that. We found the inputs and the outputs. We also know what we can do with them. We can drag them around and we can actually use the W key in order to get into the wire mode, and we could wire stuff up with each other. Of course, cable management is going to be very important here. So it wants us to get an AND gate, which we find right here on the second page. We're gonna grab that AND gate and we are actually gonna activate the grid, just because I'm a sucker for nicely arranged stuff. Okay, so we're gonna plop that right into the center here, hook those guys up. So this is an AND gate. Only if both of these inputs are on, the AND gate will also be outputting. And there we go. I think we've done everything they wanted us to do. Now we can go ahead and actually test the simulation. So one possibility is that both of the inputs are off and therefore the output is off as well. And you can see that right here, both inputs off, output off with a green check mark. So we passed the first step. Let's try another combination, which is input A on, and you can see nothing is happening. That is also good. If only input B is on, nothing is happening, but if both inputs are on, then the output is on as well. And therefore we succeeded with this first mission here. Let's go ahead and continue with the combinational logic. Now this is going to be already much harder. We have 3 inputs. We have a detonate input, a control sequence passed input, and also a detonate in haste input. Then the outputs are detonator enabled and also detonated normally. Okay, let's see what we have to do with them. Output detonator enabled shall be 1 when one of the following is true. So this guy here shall be activated when both detonate and control sequence are 1. So detonate and control sequence, yeah. Or detonate and this guy. Okay, I see. So either those 2 guys should be active or those 2 guys should be active, and this will activate this guy. Outputs detonated normally, this guy shall be 1 when both detonate and control sequence passed are 1. So if detonate and control sequence passed, If those two guys are enabled, then both of these should be enabled. Good, good, good. Let's think about that. Let's have a look into the gate section. We have plenty of gates at our disposal. Holy Moses. We're probably gonna require an AND gate. We only have a certain budget available to us, and we used $1 with this AND gate. Okay, you know what? I think the easiest way might be just to go with 2 AND gates, but I'm not sure if it is the most elegant solution. So we could, for instance, say if detonate, that is this thing, yeah, if that is active, then we have the in haste, we can plot that right here, and this guy right there. So if those two are active, then we shall activate actually both of them. So we're just gonna hook them up like so. This is a very small circuit. Let's actually test it out. I probably did something wrong. Okay, we passed the first test with all the inputs off, but that is the one you usually pass. Then we have the detonate haste on, which means both of the signals are off. That is good. Now we have the detonate on and the control sequence passed on, which means this gate is active. And oh, I just see, I cannot hook those guys up together. That doesn't make sense. I think we're gonna fail the next test. Yeah, of course, that doesn't make sense. I think what we have to do is simply take another OR gate and plot it right there, so the signal cannot pass in 2 directions. And we're gonna have that right there and there. So we can hook this up right here. And now the signal can only flow into this direction and not backwards. I think now we should be good. So first test passed, the second combination, third combination. Oh no! So now detonate in haste and detonate are enabled, which means detonate enabled. Oh, I got those guys exchanged. Let's see if we switch them around. Test again. Yeah, looking good so far. I just had those guys exchanged for some reason. I don't know why. And there we go. We passed the second tutorial. No, it's actually not the tutorial anymore. It's a real thing here. Cool. Okay, continue with truth tables. Yeah. We know all about truth tables, and this, guys, oh man, this is one heck of a puzzle. But we're gonna try to solve it together on camera. So what we want to achieve is basically the opening mechanism for doors on a bus. And for that, we have a couple of inputs. We have the driver input, so if the driver wants to open the door, then if a passenger wants to open the door by pressing a button, for instance, then we have a safety mechanism that will open the door. And finally, we have an input that signifies that the door is blocked. So as long as the door is blocked, the driver and the passenger will not be able to open the door, but the safety feature will be able to open the door. Also, we have a couple of outputs, namely open the door, of course. There we go. And also we have inform about opening, and this should only happen if not the driver is opening the door and if the door is really opening. So that means if a passenger opens the door and the door is not blocked, then the driver will be informed additionally to that the door is being opened. Okay, so let's see what we can come up with. This is not going to be easy. So if either the driver or the passenger opens the door and the door is not blocked, I think we're going to need some logic gates for that. Let's go with an OR gate first of all. I'm going to have that right here, and that means if either of these two people or inputs are trying to open the door and the door is not blocked. For that we need an XOR gate. So that means if the input signals are different, it will continue the current. So if this signal here is activated and also this guy, maybe we can make it a little bit better here. Yeah, so if the door is blocked and also one of those guys tried to open it, then the signal will not continue. Now one problem I can potentially see, what if the door is blocked but none of those guys activated the thing, then it will still output the signal, and that is bad. Let's actually have a look at the truth table here. Oh my gosh, there are so many possibilities. So those things here are the input and those two things are the output. Not sure if that helps my brain. Maybe let's go through the possibilities. If the driver opens, then the door should open, which technically will happen if we, for instance, hook this up right here. Then also if the passenger opens, then we open, but also we want to inform. So this is the passenger, and we could just drag another wire and bring this up here to the information panel, or output rather. So if we had the output right here, we're gonna try to make it as snugly as possible. Okay, so we got the second thing covered. Then if the safety feature wants to open the door, we want to do the same thing here. Oh, but the problem is that the safety open door should also inform and directly open the door, no matter if the door is blocked or not. So I don't think we can have this here. This is not good. We're gonna have to delete a few things. Holy cow, let me think about this. So what if we had another OR gate right here? That would mean if either the passenger or the safety feature wants to open the door, then we want to inform. So this will go right there. Okay, and if either the driver or the passenger wants to open, then the door shall open, but only if there's no safety signal. So here we could have the Xor Gate. This should work, shouldn't it? So if both the door blocked signal and the opening from the driver or the passenger are enabled, then this is not gonna output. Good, good, good. Okay, let's see where it fails now. I kind of lost the overview. So we successfully opened the door while the driver requested it and the door was not blocked. We got the passenger wants to open the door, the driver gets informed, and also the door opens because it was not blocked. Ah, okay, here we have our first error. The safety feature actually activated, and of course it should also open the door, but this should be easily achieved. We can simply drag a wire and open the door. So, no, this is the wrong wire. We have to take the wire from the safety feature and drag it directly onto here. This is not the most beautiful solution, but maybe we're gonna pass this next... Oh no. Of course, this cannot go like this. We have to plot an OR gate in between, so the signal cannot go back. Let's see, OR gate. We want the OR gate to go right there. Then this thing on the top, and we can hook this up. There we go. So now it can only flow into this direction. Yeah, first test passed, second test passed, next step passed. Looking good, guys. We're going through all the combinations. Nope, doesn't look good. So the passenger requested to open the door, but the door was blocked and the driver still got informed about opening the door. And of course that isn't good. Yeah, maybe we should add another Xor gate, but I will have to remove some wiring to make space. Let's see, Xor, because we only want to activate this feature here if the door isn't blocked. However, that means that the safety feature isn't gonna activate the information anymore. So maybe we hook this guy up. No, that's not good. Then I'm gonna need another OR gate. Should we do that? Should we plot in another OR gate just to test? I mean, there's probably a slicker solution, but I didn't say I'm gonna promise anything, so that should be good now. Let's see if we can go from here to there and there. I mean, it's still not the most unorganized solution. Oh, okay, this time it worked. Ooh, okay. We failed on the fourth step again. So the driver wants to open the door, but the door is blocked. Yeah, that's not gonna work. We have to reorganize the entire thing. Give me a minute. I think I'm gonna do it from scratch here. Okay guys, I think I got it this time. I had to restart from scratch. I had to make a bunch of notes, but I think we can do it. No guarantees though. Anyways, we start with our OR gate right here, and I want to hook up these two inputs. We have the driver, which is right here, and also the passenger on the other side. So that means if either of those inputs are active, then we want to open up the door, but only if it is not blocked. So here we have our blocked signal, and for that we now need the Xor gate to make sure only one signal is active. So let's maybe place that bad boy right here so we can hook this straight up, and we're gonna have this signal right there. So if the door is blocked and any of those guys are activating, it will not give off a signal, but if only one line is active, then we will have a signal. Good, good, good. The next thing we need to do is probably hook up the output here. I suspect I'm gonna need an OR gate somewhere along these lines. And we could, for instance, have this right here and then this guy on the top. Beautiful. And then we still have the space to send in another line to open up the door because the safety feature, for instance, isn't hooked up yet. And I think we could do this right off the bat. All we have to do is hook up the safety feature, which is right there. Great. Safety open. So if the safety opens the thing, it's gonna open the door, but it's also gonna inform us. And this is what this guy's for. Do we need another OR gate? I actually think so. Let's grab another OR gate. It's just $1. We're gonna have that guy right here. And the first line we hook up is the safety feature. So safety feature opens door and informs us. Then if the driver opens the door, then it doesn't inform us. And if the passenger opens the door, it doesn't inform us yet, but we can just hook it up to this guy. However, if the door is blocked, yeah guys, I have to unfortunately rearrange this. I don't have enough space. So let's see, we would have to have this like on the top here so that we have still a little bit of space. Then we could do this and that, so we can hook this guy up and this guy, and this gives me a little bit more space. It's still the same connections. This beautiful bastard we can have right there. And this is gonna hook up to the information output. And last but not least, we're going to need an AND gate, which I'm gonna hook up to the other input here. The AND gate should have a signal from this guy, and the other signal should come from the passenger. So something along these lines. Lost overview again, we have to check for errors. But I think we are actually good. So at the moment, driver opens and the door is opening. That is great. The next step is the passenger opens and the door is opening and also the driver gets informed. Then we have the safety feature is opening the door and informing the driver. We have the driver is opening the door, but the door is blocked, so it doesn't open at all, also doesn't inform us. The passenger is opening the door, but the door is blocked, same thing. Then we got the door is blocked and the safety feature is on and it is still opening the door and informing the driver. Then we have the driver opens the door, but the door is blocked. However, the safety feature is on as well and therefore the door is opening and informing the driver. Oh, this is ingenious. I'm so proud of myself. We got the passenger who tries to open the door. The door is blocked, but the safety feature is on. So there we go. Same thing basically. Then we have the driver and the passenger are opening the door, which is still informing the driver, so that is good. Now the driver is opening the door, however, the safety feature as well, and therefore we get informed. Oh no, we have an error with the last possibility. So if the door is blocked, it at the moment sends out the signal to open the door, which of course is nonsense. Maybe we could use an AND gate here. That means the output is 0 if both inputs are 1. But this just became a whole lot less elegant here. And it's also faulty. Holy Moses. Okay guys, I think I fixed it. Yeah, we're going through all the tests successfully. The only thing I did is I added an AND gate here and I hooked it up with this signal. So if any of these two people are activating the button, and this signal here is active. So if they really pressed the button, then the signal will pass through. If only this feature, the door blocked, is enabled, then we will only have one signal here and the signal from the other guys is not coming. Therefore, it's not gonna continue. And this time we should be passing through the 11th test. Yes, indeed. And the solution rating is only 75%. And by the way, these 17 minutes are not correct. I've been going back and forth between the levels, restarting them over. But yeah, now we could continue with additions and everything. I mean, it's crazy, guys. There's so much stuff in this game, up to the point where it definitely would get too complex for me. But I mean, why the heck not? I mean, I'm sure we can go through most of it, probably, at least together. But yeah, I'm really interested in how memory cells are done logic-wise. So that might be interesting. But yeah, other than that, I would say we're gonna wrap it up right at this point. Thank you so much for watching. I hope you enjoyed this first look. Have a great time and see you soon. Bye bye.